In this video, we will begin solving this circuit by superposition by focusing on the situation where we focus on the 20-volt battery, which is drawn up here. You see that the current source has been broken out of the circuit. There's no wire involving it whatsoever. We will solve this using mesh analysis with two loops. I've chosen my loop directions to be clockwise because I think that best matches the battery directions. However, I might be wrong. It's okay if I am. It'll solve itself in the end. I'll carry on my analysis by selecting terminals for all of the resistors. Then, given my terminals, I'll name all my voltages. I'm just going to label them with the values of their resistors. Now I can determine equations for V1, V2, V3, V4, and V5 in terms of currents I1 and I2. V2, for example, is only affected by I1. I1's current direction matches the convention, so V2 is simply equal to I1 times 2. If the terminals were opposite, plus minus, then I would have to write that V2 equals negative I1 times 2. V3 is affected only by I1, and I1 matches the sign convention for V3. V5 is affected only by I2 and matches the sign convention for I2, and V4 is similar. So V3 equals I1 times 3, V4 equals I2 times 4, and V5 equals I2 times 5. V1 is slightly more complicated because both I1 and I2 contribute to the voltage drop in this direction. I1 runs from the positive terminal to the negative terminal, so it pretty normally causes a voltage drop across the 1 ohm resistor. Obviously, I2 is supposed to contribute a voltage drop of its own, but its voltage drop is in this direction, from left to right. So we can say that I2's effect is to decrease the voltage drop in this direction, because I2 is supposed to cause a voltage drop in the opposite direction. Basically, we can say that the contribution of I1 is positive and the contribution of I2 is negative, and then we multiply that by the value of 1 ohm. Just rewriting all these to look a little more sensible. There we go, I am much happier. Now that we have expressions for all the voltages, let's write down our KVL equations. For I1, we start from the dependent source. It's a rise in the loop direction, so it's plus 5I0. Then we drop across V1 and drop across V3 and drop across V2, because you go from the positive terminal to the negative terminal, which is a drop. So it's minus V1 minus V3 minus V2 equals 0. Now for loop 2, let's start from the 20 volt. That is a 20 volt rise and then a V5 drop. And then here we go up from negative to positive. So it's plus V1, then it's positive to negative, minus 5I0. Then it's drop across the 4 ohm resistor, minus V4 equals 0. Now we have one issue. We're going to be substituting all of these V's to be in terms of I1 and I2, but we also have this extra variable I0. So let's express I0 in terms of I2 or I1. Think about it for a little bit. In terms of I1 and or I2, what is I0? Give it a moment to pause. I2 equals negative I0, or I0 equals negative I2. That's because I0 is expressed in this direction, and I2 is expressed in the opposite direction. Now we are ready to convert everything. For I1, negative 5I2 minus I1 minus I2 minus 3I1 minus 2I1 equals 0. This resolves to negative 4I2 minus 6I1 equals 0. An interesting thing you may be able to note from this equation is that I1 and I2 must have opposite signs, so one of them we marked wrongly, but that's okay. For I2, we still have 20 volts, and then we plug in minus 5I2 plus I1 minus I2, and then minus 5I0 becomes plus 5I2, and then it's minus 4I2 equals 0. After dividing this equation by 2 and moving the parts of this equation that have variables to the right, we have the following system of equations, which I'll solve by multiplying this by 3 and adding it to this equation. We are then left with 17I2 equals 60, which says that I2 equals 60 over 17, which is really annoying, but at least it gives us I0. So we know that I0 equals negative 60 over 17 amps for this version of the circuit. This is not I0 for the total circuit. This is only part of I0. We will now proceed to analyze this version of the circuit.